Imagine an invisible force field, a cosmic guardian wrapping our entire planet in a protective embrace. This isn't science fiction, it's Earth's magnetic field, a vast dynamic structure generated by the swirling ocean of molten iron deep within our planet's core. For more than 4 billion years, this field has been our silent defender. It stands guard against the solar wind, a relentless stream of charged particles blasted from the sun. Without it, this cosmic radiation would strip away our atmosphere, boil our oceans, and render the surface of our world sterile and lifeless. It's the unsung hero of our planet's story, the reason life was able to take hold and flourish. But this shield is not static, it's a restless, shifting entity. The geographic north and south poles are fixed points, the ends of the axis our planet spins on. The magnetic poles, however, are wanderers. And throughout Earth's long history they have done something truly extraordinary. They've completely flipped. The magnetic North Pole becomes the South, and the South becomes the North. This is a geomagnetic reversal, a natural, albeit dramatic, part of our planet's geophysics. It's written in the rocks, in ancient lava flows that cooled and locked in a snapshot of the magnetic field's direction at the time of their formation. These reversals aren't a rare occurrence, at least on geological timescales. On average they happen every 200,000 to 300,000 years. Yet the last full reversal took place about 780,000 years ago. We are, by this measure, long overdue for another. Scientists have observed that the magnetic field has been weakening over the last 160 years, a potential prelude to the next great flip. This isn't a sign of an impending apocalypse, but a reminder that we live on a dynamic world, one that is constantly changing both on its surface and deep within its metallic heart. The process is a fundamental feature of our home. The question, then, is not if it will happen, but when and what it will be like. A reversal isn't an instantaneous switch, it's a long, drawn-out process that could take centuries, even 1,000 years to complete. During this transition, the main magnetic field, our primary shield, would weaken significantly, perhaps to as little as 10% of its current strength. Multiple smaller, weaker magnetic poles might pop up in random locations across the globe. Our planet's defenses would be in a state of chaotic flux, leaving us more vulnerable than ever before to the harsh realities of space. It would be a time of profound change for every living thing on Earth. As the magnetic field begins its long, slow journey of reversal, its weakening would invite a new reality for our planet. The first and most profound change would be our increased exposure to cosmic radiation. Our atmosphere would still provide a substantial layer of protection, just as it does today. But the magnetic field is the first line of defense, deflecting the most energetic particles. With that shield compromised, more solar and cosmic rays would penetrate deeper into our atmosphere. These high-energy particles would start to shred our ozone layer, the delicate atmospheric band that filters out the sun's most harmful ultraviolet radiation. This assault on the ozone layer would have direct and dangerous consequences for our health. Imagine a world where a few minutes of sun exposure is enough to cause a severe burn. With a severely depleted ozone shield, rates of skin cancer would skyrocket, potentially becoming as common as the seasonal flu. The increased ultraviolet radiation would damage DNA in all living things, leading to higher mutation rates and unpredictable effects on ecosystems. Some regions of the planet, particularly those at higher altitudes, could become functionally uninhabitable for humans, forcing mass migrations as people seek refuge in less exposed areas. We would have to rethink our entire relationship with the sun. The sky itself would transform. One of the most beautiful side effects of this geomagnetic chaos would be a dramatic increase in auroras. Today, the glorious northern and southern lights are mostly confined to the polar regions, a spectacle few get to witness. But with a weakened and fractured magnetic field, solar particles would rain down into the atmosphere at all latitudes. The skies over Tahiti could shimmer with the same ethereal green and purple lights currently seen in Alaska or Norway. Auroras would become a global phenomenon, a constant, beautiful reminder of our planet's vulnerability, but this celestial light show would come at a steep price. The very particles creating these beautiful displays would be wreaking havoc on our technological civilization. The constant bombardment would pose a grave threat to everything we've built in orbit. Satellites, the unseen backbone of our modern world, would be the first casualties. These sensitive electronic devices are not designed to withstand such a persistent bath of radiation. Their circuits would fry, their memory corrupted, and their systems would fail one by one. Our window to the cosmos and our ability to communicate across it would begin to close. The failure of our satellite network would trigger a cascade of disruptions that would grind modern society to a halt. We rely on satellites for so much more than television and weather forecasts. They are the master clocks of our globalized world. The Global Positioning System, or GPS, doesn't just tell you how to get to the grocery store, it provides the precise timing signals that synchronize everything from international banking transactions to the flow of electricity through our power grids. Without these satellites, the intricate dance of modern logistics and finance would collapse into chaos. Supply chains would break, and the global economy would face an unprecedented crisis. The damage wouldn't be confined to space. The same solar particles that create auroras can induce powerful electrical currents in long conductors on the ground. Our power grids, with their thousands of miles of high-voltage transmission lines, are essentially giant antennas, perfectly positioned to absorb this energy. A major solar storm hitting our weakened magnetic shield could induce currents strong enough to overload and destroy critical transformers on a massive scale. A single powerful solar event could trigger a continental or even global blackout that could last not for days or weeks, but for months or even years. Consider the consequences of a world without electricity. Your phone would be useless, not just for calls, but for everything. The internet would vanish, lights, refrigeration, and air conditioning would be gone, but the problems run deeper. Modern water and sewage systems rely on electric pumps to move water and waste. Without power, clean water would stop flowing to our taps, and sanitation systems would fail, creating a dire risk of disease. Our civilization is a towering structure built on the foundation of electricity, and a prolonged blackout would bring that structure crumbling down, sending us back to a pre-industrial existence. The economic toll would be staggering. Experts estimate that a severe solar storm, even with our current magnetic field, could cost the United States economy upwards of $42 billion per day. In a world with a compromised shield, that number would be astronomically higher. The cost of replacing thousands of giant transformers and rebuilding a shattered grid would run into the trillions. The immediate economic shock would be devastating, but the long-term challenge of rebuilding our entire technological infrastructure in a high-radiation environment would be one of the greatest tests humanity has ever faced. Humans and their technology would not be the only ones struggling in this new world. Many species in the animal kingdom possess a sense that we lack magnetoreception. They can perceive and use Earth's magnetic field as a natural compass for navigation. Migratory birds, sea turtles, salmon, and even tiny honeybees rely on this internal guidance system to undertake incredible journeys across continents and oceans. They follow invisible magnetic pathways to find breeding grounds, feeding areas, and seasonal homes. A flipping magnetic field would be like taking away their map and compass in the middle of a vast, featureless wilderness. The transitional period of a reversal, with its weak, fluctuating field and multiple poles, would sow confusion. A sea turtle, hatched on a beach in Florida, might swim in circles, unable to find the Gulf Stream that guides its journey. A flock of Arctic terns, attempting their pole-to-pole migration, could become hopelessly lost, ending up in the wrong hemisphere or perishing from exhaustion. Salmon might be unable to find the specific river where they were born to spawn. This disorientation would threaten the survival of countless migratory species, disrupting the delicate balance of ecosystems that depend on their seasonal movements. However, the fossil record offers a message of hope. These pole reversals have happened many times before, and life, in its incredible tenacity, has survived them all. No mass extinction event has ever been directly linked to a geomagnetic reversal. This suggests that while individual animals and generations might struggle, species possess a remarkable capacity for adaptation. They may have backup navigation methods, such as using the position of the sun, the stars, or their sense of smell. Over generations they could adapt to the new magnetic geography, just as their ancestors did countless times before. The challenge for wildlife would be the pace of modern environmental change. In past reversals, animals faced a shifting magnetic field, but a relatively stable climate and ecosystem. Today, they are already under immense pressure from habitat loss, pollution, and climate change. A geomagnetic reversal would be an additional profound stressor piled on top of these existing challenges. The combined pressures could push already vulnerable species over the brink. The survival of many of these incredible navigators would depend not just on their own resilience, but on our ability to mitigate the other pressures we are placing on them. The prospect of a geomagnetic reversal is daunting, painting a picture of technological collapse and global disruption. But it's crucial to remember that this would not be an instantaneous event. The flip would unfold over many human lifetimes, giving us time to observe, understand, and adapt. It would not be a surprise cataclysm that strikes overnight, but a slow, creeping change that we could prepare for. Humanity is, above all, a species of toolmakers and problem solvers. Faced with such a predictable, long-term threat, we would undoubtedly rise to the challenge of protecting our civilization. Our first priority would be to harden our infrastructure. We would need to design and build a new generation of satellites with enhanced radiation shielding. We could develop more robust power grids with safeguards against geomagnetic induction, such as installing blocking devices on transformers. We might even shift toward more localized, decentralized power generation, making the entire system less vulnerable to a single point of failure. It would require a monumental global effort of engineering and investment, a proactive endeavor to retrofit our world for a new geomagnetic age. Our survival would depend on our foresight and cooperation. Daily life would change in fundamental ways. Architecture would evolve to incorporate UV-blocking materials and designs that minimize sun exposure. Outdoor work might be restricted to early morning, evening, or nighttime hours. We would develop new social customs and technologies centered around living in a higher radiation environment. The beautiful, ever-present auroras would become a part of our global culture, inspiring new art, mythology, and science. We would adapt, not just technologically but culturally, to the new sky above us. It would be a different world, but it would still be our world. Ultimately, a magnetic pole reversal would not be an extinction event. It would be a profound, civilization-altering challenge. It would force us to confront our dependence on fragile technology and our vulnerability to the cosmic forces that shape our planet. But it would also be a testament to our resilience. Like the many species that have navigated these reversals before, humanity would find a way to endure. We would learn to live under a shimmering auroral sky, with a new compass to guide us, having weathered one of the most fundamental changes our planet can undergo. The transition would be difficult, but on the other side, we would be a more robust and adaptable species.